Alright, welcome back to my YouTube channel, Wassce Tutorials. We see where mathematical literacy begins. Alright, so today we are coming to solve the compulsory aspect of the Wassce 2025 questions. They just ended Wassce 2025 questions. Very simple questions. Make sure you sit down with your pens, your jotters, your calculator, pencils, everything ready. Put anything aside that will be as a form of distraction to you, and pay attentively to whatever thing will be going on your screens. Alright, so let's dive in through these compulsory questions successfully. Now we are starting with question 1, which is average speed. That's the combined rate. Very simple. Make sure you follow this tutorial successfully. Alright, so let's go. Question 1. A bus travels between two stations, Paga and Kappa, covering the first half of the distance at an average speed of 60 kilometers per hour and the second half at 90 kilometers per hour. The total distance between the two stations is 300 kilometers. A. Calculate for the entire journey the average speed of the bus. B. If the speed of the bus in the first half of the journey is reduced to 50 kilometers per hour, determine its effect on the overall time. That's the overall journey. So let's see. Solution. Now, a bus travels between two stations. We have Paga here, Paga then Kappa here. So a bus travels between two stations here. Now, covering the first half of the distance at an average speed of that. So, which means it is half of that. The total distance is 300 kilometers. That's the total distance. So, first half of the distance is 150 kilometers, which means we divide the entire distance by what? 2, because they said what? First half of the distance, and the second half is also 150 what? Kilometers. That's the second half. So now let's deal with the first part. And the first part is what? The first half of the distance. Okay, so the first part, don't forget, average speed is equal to the total distance covered all over the total time taken. That's the average speed formula. So now here we can just write, let's see, speed is equal to distance over time, but make sure you write it in full. Average speed equals the total distance covered over the total time taken. So now for the first part, that's the first half, we know the distance to be 150 kilometers and the speed is 60. So the speed 60 is equal to the distance 150 over the time. So now by cross product, we have 60t equals, it's still 150. 1 times 150 is 150. We want t, so it will be 150 over 60. 0 cancels 0. So that we have 15 divided by 6. And this is just 2.5 hours. 2.5 hours. So that's the time for the first part. That's the first half of the distance. So the bus used what? 2.5. That's 2.5 what? Hours, or 2 hours 30 minutes to cover the first half of the distance. That's 150 kilometers at a speed of 60 kilometers per hour. Now let's see the second part. Let's see, the second part is just here. The second part, that's the second half of the distance. The same thing, speed is equal to distance over time. So speed equals distance over time. The speed for the second half is 90 kilometers. So 90 equals, the distance is still 150 over what? T. So speed is equal to distance over time. By cross product, we have 90t equals 1 times 150 is still 150. We divide both sides by 90. So this guy cancels, so that we have 15 divided by 9. And this will give us 1.67 hours. 1.67 hours. That's the second part of the journey. So the second half of the distance, the time is what? 1.67 hours. Now the question says calculate for the entire journey the average speed of the bus. So for the entire journey, what will be the time taken? Don't forget, for the entire journey, the distance is what? 300 kilometers. For the entire journey, the distance is 300 kilometers. So we have to find for the entire journey what will be the time for the entire journey before we can calculate for the speed of the entire journey. So time for the entire journey, and this is equal to 2.5 plus 1.67. okay, so 2.5 plus 1.67, and this will give us 4.17 hours. 4.17 hours. Now the A part says calculate for the entire journey the average speed of the bus. So calculate for the entire journey the average speed of the bus. So now the speed is equal to, that's the entire journey, the distance for the entire journey is 300 over 4.17. So speed is equal to 300 divided by 4.17, and this will give us 71.94 kilometers per hour. 71.94 kilometers per hour. So this is the A part. So the speed for the entire journey is this, the distance for the entire journey, which is 300, then the time for the entire journey, which is 4.17. So the speed will be what? 71.94 kilometers per hour. So if you don't understand, please play back the video for better understanding. Now let's see the B part. If the speed of the bus in the first half of the journey is reduced to 50 kilometers per hour. So the first part, which is the first half of the distance, the speed for that, it was 60, and this time around we've reduced that to 50, so which means a difference of 10. So it is now 50 kilometers per hour, and which means that for the second part of the journey, the speed is unchanged, is the same, which is still what? 90 kilometers per hour. So now let's see, we are solving for the B part. So if the speed is now 50 kilometers per hour, what will be the time there? The distance is still 150 kilometers. So the speed is 50 is equal to, that's 150 over t. So by cross product, we'll have 50t equals 150. So t will be equal to 150 over 50. This one cancels, so that we have 3 hours here. So 3 hours. So for the first part, the time is what? 3 hours. And the second part, the time is still what? 1.67 hours. The time is still 1.67 hours. So if you check, if you reduce the first part, the speed, to 50 kilometers per hour, the time is 2.5 hours. So if you reduce it to 50 kilometers per hour, the time is what? 3 hours. And when you increase the speed to 60 kilometers per hour, the time is what? 2.5 hours. So this one is clearly what? An indirect proportion. An indirect proportion. So if you increase the speed, the time limit will go down. But when you decrease the speed, the time limit or the time factor will increase. So it's an indirect proportion. Alright. Now, the question says, determine its effect on the overall time, not only the first part. We have to draw a conclusion on that. No, the question wants what? The effect if you reduce the speed for the first part to be 50 kilometers, what will be its effect on the overall, which means the entire journey, what will be its effect. So that's what we want to look at. Now, let's see. This is the time for the entire journey. Initially, the time for the entire journey, using the speed 60 kilometers per hour for the first part. Initially, so the time for the entire journey, which is what? The entire journey, the time taken was 4.17 hours. And now, we want to find for the new time when the speed is reduced to what? 50 kilometers. So we want to find for the new time when the speed, so new time when the speed is reduced to 50 kilometers per hour. So now this time around we'll get it as what? 3 hours. So it will be 3 hours plus, don't forget the second part, because the speed is the same, the time to remain what? Unchanged. So still 1.67 hours. So when we add this up, 3 plus 1.67, and this will give us 4.67 hours. This will give us 4.67 hours. So now, new time when the speed is reduced to 50 kilometers per hour for the entire journey. New time when the speed is reduced to 50 kilometers per hour for the entire journey. So this one is for the entire journey. It is 4.67 hours. Now, this one when the speed is 60 kilometers per hour, which means they've increased the speed to 60 kilometers per hour. That's initially it was 4.17 hours. So now what will be its effect on the overall time? Now let's check for the difference. The difference in the time. Difference in time. And this is 4.67 hours minus 4.17 hours. So, and this is 0.5 hours. And 0.5 hours, that's half an hour. And this is 30 minutes. 30 minutes. So, what we can say here is, if the speed of the bus in the first half of the journey is reduced to 50 kilometers per hour, the effect on the overall time will increase by what? 30 minutes. That's all. So let's meet in our second question. If you don't understand, please play back the video for better understanding. See you.